Hello and welcome to this video. We're going to be talking about the average rate of change, which is a concept that comes up quite a bit in AP Calc, but I think is a bit glossed over. And while it's a somewhat straightforward concept, I think it was worth taking some time to do a video about it, so that way you feel really strong about it, and when this word average gets put in front of a rate of change, you know exactly what they mean by that. So this concept, an average rate of change, is really one that you are familiar with already, and it's just being called by a different name. So average rate of change really just means slope. And so while you might think though, you're like, well, average though, why is it different from just what we talked about like in the last video where we formally defined the derivative in the last video? You might be wondering, well, how is it different now when we put that word average out front? So what I've done is put this formula down here, and this formula is the formula for the average rate of change of some function f of x. So hopefully you see that this is somewhat familiar already, because right here we have f of b minus f of a on the top. And f of b and f of a are both going to be y values, right? If we have some function f of x and we plug b and a into it, we're going to get out some y values. So hopefully you see on the top that if we subtract two y values, we're going to have some change in y. And then the same thing on bottom. B and a represent values that you're plugging into this function. They represent some sort of x value. So when we take two x values and subtract them, we're going to have a change in x. So this formula right here is the delta y over delta x, or rise over run formula that you're really used to seeing. This is how we would calculate slope when we had a linear function. So that's exactly what the average rate of change is. It's calculating slope. But why is it called average? Well, if we have some function that is curvy, so this is not a straight line, and then I have some spot A, and I have a spot B. Again, A and B represent some x values on the x-axis here. So if this was my function f of x, and I wanted to know what the average rate of change was of this function, what I ask what's the average rate of change between the x values of A and the x values of B. So an average rate of change is saying, look, I know that this is a curvy function, and if I have a curvy function, if it's not linear, then that means the slope is going to be different at every single point on this function. So if I want to give an exact slope, an exact rate of change, I would have to give one at one point of this function. I could not say that the slope between A and B was all just the same, right? Because obviously this function is getting steeper and steeper as we move from A to B. But I can define something called the average rate of change. And what that means is if I were to draw a line from A to B, so right here I've drawn a straight line that connects A to B, what the average rate of change asks is, what's the slope of this line? And hopefully you remember that this is a secant line because it touches our function twice. That's what makes it a secant line. So an average rate of change goes, okay, I know that the exact rate of change on this function is going to be different everywhere, but I want you to just find the average or an approximation of this function's slope between A and B. Because as you can see, this red line is not going to have the exact same slope as this black function, but it does a decent job of approximating the slope, right? If we were to find the slope of this red line, maybe the slope was 3, it's not going to be the slope of this black line, but it's an approximation. It's the average between points A and B. So that's all the average rate of change asks you to do, is it specifies, it says, okay, start at A, some x value A, and end at some x value B. And then draw a secant line between those 2 points, and then find the slope of that secant line. And that is going to be your average rate of change. So it's really just taking some curvy function and using a straight line to approximate that curvy function slope. So a question you might get asked then is, the question will say, okay, we have some function f of x, and let's say we're dealing with the function x squared. The question might ask you, find the average rate of change, and the average rate of change gets abbreviated to ARC. It's common. So find the average rate of change between an x value of 2 and an x value of 4. So this is what the question gives you. It says, okay, here's your function that you're going to be finding the average rate of change of, and these are the 2 points that you're going to be finding the average rate of change between, right? Because average rate of change is the slope of a secant line. A secant line touches the graph or the function twice. So in order to find the slope of that secant line, we need to know where that secant line starts and ends. So it might be helpful to draw a picture here. We know what f of x equals x squared looks like, so that's a parabola. It goes up like that in the first quadrant. So we'll say that 2, we'll put 2 right there, and we'll say that 4 is right there. So if we want to find an average rate of change between these two x values, what we need to do is find the slope of a secant line. So it might be helpful to draw the secant line of this function. So in green here, I've drawn the secant line that connects the point at x equals 2 and the point at x equals 4. And so we want to find the slope of this secant line. So to do that, well, we have a straight line, so it's just going to be our rise over run situation. So if we're doing rise over run, that's exactly what this formula right here tells us. F of b minus f of a is going to be our rise, and b minus a is going to be our run. And so in this situation, our a is going to be this value, and our b is going to be this value. So if we plug that into our formula, we know that our b is going to be 4 and our a is going to be 2. So now we just need to know what f of b and f of a are. Well, f of b means plug b into this function. So if b is 4 and we plug 4 into the function x squared, we should get out 16. And then we can do the same thing with a. F of a means plug a into this function. So if we plug our a value 2 into this function, we should get out 4. And so this is going to be our average rate of change. And so we can simplify that. 16 minus 4 is going to be 12. And 4 minus 2 is going to be 2. And then 12 divided by 2 is 6. So we would say that the average rate of change of the function x squared between 2 and 4 is 6. So 6 means the slope of this green line, the slope of that secant line, is 6. And we figured that out by just using this rise over run formula. So this is all an average rate of change asks you to do. It's just asking you to find the slope of a secant line, and it'll tell you where the secant line should start and end. You might have to go figure out the y values yourself like we did, but it'll specify where each endpoint of your secant line is. So this is something that I see a lot of students getting a little tripped up on, is when they see that word average out front, especially as you continue on in AP Calc and you start learning all sorts of new things about the derivative and lots of derivative rules. It's really easy when you get to the AP test to all of a sudden be hit with this word average rate of change, and you're sitting there going, wait, what does it mean when we put average out front? I know what a rate of change is, I know what the derivative is, but how is the average rate of change different? So this is all an average rate of change asks you to do. So make sure you remember this. This is very, very commonly forgotten, and I think it's pretty straightforward, but it's just remembering how do we define an average rate of change. So hopefully this video is helpful. As always, if you have any suggestions or improvements or any concepts you want to see, leave that in the comments below, and make sure to subscribe.